All right, guys, in this video, we're going to take a look at trapezoid properties. So at this point, we've talked about parallelograms, rhombuses, rectangles, squares. What we have left is just the trapezoids, okay? Now, you might be asking what's so special about trapezoids? Well, I'm so glad you asked. Let's take a look. So here's your key definition with trapezoids. A trapezoid is a quadrilateral with only one set of parallel sides. So notice there's kind of two conditions happening here. It's a quadrilateral, it has four sides, and only one set of parallel sides. Now remember, parallel means going in the same direction, not necessarily the same length, and we use the arrows to indicate one set of parallel lines. So using that and what we know about parallel lines, let's solve a couple problems. Oh, wait, hang on. We've got some more properties. So because of those parallel sides, so that is one of the properties, the angles between the bases are supplementary. So when we talk about bases, what we're talking about is the parallel sides. It doesn't necessarily mean top and bottom. It just means the sides that are parallel. Now, the ones between those, so the red angles and the blue angles, add up to 180. And the reason they add up to 180 is that this is an angle pair from parallel lines. These are our same side interior angles. Now, if you don't remember that, that's okay. But I want you to understand where this is coming from. So if this angle is 80, this one would be 100. But that doesn't mean that this angle over here has to be 80. This could be, I don't know, like 75. And this one would over here would be 105, okay? So what we're saying is not necessarily that the base angles are congruent and the top angles are congruent, but that the angles next to each other add up to 180 if they're in between the two parallel lines. So let's solve some problems here. So one of them here, let's solve for x. So notice, I should probably put some parallel lines on here. All right, so these two are going to add up to 180. So I'm going to do 180 minus 68. And I'm going to get 112 here for x. There we go. And then for y, we're going to do 180 minus 147. And I'm going to get 33 for y. All right, very good. Let's look at one solving problem that deals with not just solving for an angle, but actually solving for x. So notice I've got 51, I've got 3x minus 27. What we want to do before we set up any of the equations, we want to say, what do I know for sure? Well, I know that these two angles add up to 180. Now that's going to tell me how to set this thing up. What I'm going to do is I'm going to do the exact thing that I just said. I'm going to add them up to 180. So add them up, set them equal to 180. All right? Now, just like we always do when we're adding things together and setting equal to 180, we want to simplify one of the sides. So we've got 3x here, minus 27 plus 51. So that is going to come out to something like 24 is equal to 180. All right, now notice if it's on the same side of the equation, we're going to use the same signs, minus 27 plus 51. We're not going to do the opposite. Now, if we're going opposite sides of the equal sign, we're going to use our opposite signs. So I'm going to do minus 24 on both sides here. So I get 3x is equal to 156. And I'm going to divide by 3, and I get x is equal to 52. So notice how we did that. We added them up, set them equal to 180. We did not set these equal to each other because they're not equal to each other. Look, these angles don't look the same size, so don't set them equal to each other. All right, now there's a special kind of trapezoid, and that's called an isosceles trapezoid. Now let's see if we can think back to a time we talked about isosceles shapes. We also talked about with isosceles triangles. Remember, isosceles triangles look something like this. Okay, where two of the sides are the same size. So the same thing here, the isosceles trapezoid has two sides that are the same size. Now notice they're not the bases, we call them legs. So the parallel ones are bases, and the ones that are not parallel are called legs. So an isosceles trapezoid has one set of parallel sides, and that should not say on, that should say one set of congruent sides. All right? So let's look at two properties and then we'll solve a couple problems and we'll wrap this video up. So isosceles trapezoids. One thing to know is that the base angles are congruent and the diagonals are congruent. So the old rules still apply. The angles between the bases add up to 180 still, but notice now we know for sure. So if this one here is 50 degrees, this one over here will be 50 degrees, okay? So it actually makes our solving a little bit easier. And then we also know that the diagonals are congruent. Now there's one other shape out there that has this property, well, technically two, with the diagonals being congruent. See if you remember which one that is. It's one of our parallelogram properties, not the parallelogram, but inside our parallelogram family. And it's actually the rectangle. The rectangle also has diagonals that are congruent. And so then the square has diagonals that are congruent as well. But that is a property of rectangles. So sometimes people like to be a little bit tricky and try and fool people by saying, oh, the diagonals are congruent. And then you say, oh, I know that's a rectangle property. Well, it could also be an isosceles trapezoid property. So you have to look at some of your other information to know for sure. So let's go ahead and solve a couple problems. So let's say I know that this corner is 58. Let's solve for all the other corners. So I know that base angles are congruent. And I know that angles between the bases add up to 180, just like we did before. So we're going to say 180 minus 58, and I get 122 on each of these. All right? And we're done. That was pretty easy. All right, let's look at something like this. Now remember, let me put some arrows here. Remember, your parallel lines are still the bases, even though they're not on top and bottom. So what do I know about these two angles? Are they equal to each other, or do they add up to 180? Those are really my options. Well, if I look, I remember that the base angles are congruent. Okay? They also look congruent. They're both acute angles. So I'm going to set these equal to each other. 2x plus 53 is equal to 3x plus 41. All right, so I'm going to start by subtracting 2x from both sides. So I get 53 is equal to x plus 41. This one's going to come out pretty nicely. I'm going to subtract 41 from both sides, and I get 12 is equal to x. And I could always plug that 12 in if I was looking for an actual angle. If I wanted to find the angle measure, I could plug that 12 in, but in this case, we just need to solve for x. All right, last problem, let's solve for x here. Now notice these are on the diagonal, and what do I know about diagonals? I know they are congruent to each other, so I'm going to set this up. 24 is equal to 3x minus 9. So just a little hint, if it's a diagonal or a side or something like that, we are never adding those up to 180. Okay, so never set sides to 180. That's something we only do with angles. It's not the only thing we do with angles, but we only do adding to 180 for angles, not with sides. All right, so let's add 9 to both sides. So we get 33 is equal to 3x. I'm going to divide by 3, and I get 11 is equal to x. All right, so that wraps up our properties of trapezoids and isosceles trapezoids. Remember, trapezoids have 4 sides and 1 set of parallel lines. And we know that the angles between the bases add up to 180. We also know for isosceles trapezoids, we know that it has not just 1 set of parallel sides, but a second set, a different set of congruent sides. And that gives us base angles that are congruent. It also gives us diagonals that are congruent. So with this information, you should be able to solve problems for trapezoids.